Welcome to a new lesson, actually the last lesson of the unit for Unit 9, Part 2, or Part 1. And this is basically using all the methods to find missing sides of a right triangle and kind of mixing them together. So you're going to figure out what method do I need to use to solve for the missing side or missing value of x. So there are four options. There is the easiest one, which is the Pythagorean theorem. So there's one, right? There's option number one. The other option is using the geometric mean. And that similar triangles. That's where we have an altitude. Which splits up the triangle into a small, medium, and large triangle. And then we have the 45, 45, 90 right triangles. And last but not least, we have the 30, 60, 90 right triangles. So ultimately, there are four different methods that we need to use. Now, are we going to use all of them? No. Depending on the problems that we're working through, we can use one of these four. So with number one, whenever you see an altitude drawn that splits a triangle into two equal parts, you got the saw. You're probably going to be using option number two, right? So there's one number one. This is number two, number three, and option number four. So number two involves the altitude, which we have here. Now, are you using the small triangle, the big triangle, the medium triangle? Well, it depends. You need to have two sides for each triangle. And if you look at the big triangle, we only have one side. So logic tells me that I'm going to be using the medium and the small. Color it in with different colors, red and green. All right. So it's different color as well with that one. So we got the green triangle, which is the medium sized. Has a side length, the longest side is going to be 25, or longer leg, and the shorter leg is going to be x minus 4. And then we're going to do the same with the small triangle, which is to have the same orientation, and we're going to match up the sides. Now it looks like out of those two sides that the x minus 4 is the longer leg and the 9 is the shorter leg. So here's that red triangle that I was talking about, and this is the green triangle, the medium-sized triangle. So we know that they're similar. Now we're going to set up the proportions. So according to my formulas, or not formulas, but rather the matching up the sides, 25 goes to x minus 4 on the red triangle, and on the green triangle, x minus 4 goes to 9. So when we do that, we're going to cross multiply, which gives us x minus 4 times x minus 4, which equals 25 times 9. Okay. And then we're just going to simplify this. This can actually be combined into one thing, which is x minus 4 squared. Now, 25 times 9, you can plug it into your calculator, and you get 225. And I want to get rid of the squared, so I square root to both sides. Okay. Now, x minus 4 is what we get after we do the square root. and here we get 15. Well, technically, you actually also get negative and positive 15, but that's something we'll talk about later. So we just get 15 here. We're going to add 4 to both sides. These cancel out. X is equal to 19. And there's your answer. So whenever you got an altitude, you're probably going to use option number 2, the geometric mean. Okay. So if you need to pause this video, obviously pause it so you can get the work down. I'm going to move on to number 3. Now, number 3 looks like a word problem. This is the altitude of an isosceles triangle. So, we may be using the altitude and leg theorem. So, of an isosceles triangle. So let's draw that triangle. Isosceles. Remember, isosceles means that 2 sides are congruent. So I'm going to try to draw best I can an isosceles triangle. So these 2 sides are congruent. And the altitude, so the distance from here all the way down, straight down, is going to be 6. So we know that's going to be 6. We know that splits it up in 2 congruent parts. And we know that the base is going to be 14. So if that's the case, then this is going to be 7, this is going to be 7. We need to find the legs of that isosceles triangle. Well, hopefully you notice that if I look at just the triangle by itself, within the triangle I mean, so not just the isosceles triangle, I have 2 sides and I need to figure out the third side. So I'm going to redraw it here. No mention of angles, so probably not going to use the 45-45 or 30-60-90. But we do know that we have a side here, which is 6, and a side here, which is 7. And we need to find the third side. Well, if you're trying to find the side of a triangle and you're given 2 sides already and only 1 triangle, we're going to be using option number 1, Pythagorean theorem. So we needed simplest radical form, so you set it up. Obviously, this is going to be C because that's the hypotenuse. So you set it up. 6 squared plus 7 squared is equal to C squared. Then you just break it down. 36 plus 49 is equal to C squared. Add them, you get 85 is equal to C squared. And square root both sides. And you get C, the square root of 85. Now, if we were to break it down, it would break up into 17 and 5, which is not a perfect square. Neither of them are, so we're going to leave it alone. So there's your answer. Okay. Next one is number 5, and that's the last one. Number 5 involves 2 triangles, and they're both different. They're not the same. So we need to find, I'm actually going to highlight them. We're going to call this one, this is going to be yellow. And the other one's going to be green. So if you look at the yellow one, we're trying to find x. That's the whole point. But we don't have any values for the sides aside from x. So we're going to look at the green one. The green one, and I'm going to redraw it by itself, has a side length here of 7 radical 2. And we also have the angle, which is 60 degrees. Then we're going to use the special right triangles. So we know that this is going to be 30 degrees. And we know, hey, we need to find the side that they share, which is this side right here. So we'll call that A. Okay. So that is the green triangle that I kind of separated away from the yellow one. And we're going to find out what A is going to be. So we're going to use special right triangles. So we got triangle right here of 60 degrees, and you got 1, radical 3, and 2. So now we just match up the sides. I'm going to start with the variable that I'm looking for, which is a. A is going to 1. So a goes to 1. And then we got 7 radical 2 goes to 2. So 7 radical 2 goes to 2. And at this point, we're just cross multiplying. So 2 times a is just 2a. And 7 radical 2 times 1 is just 7 radical 2. So here, we just divide by 2 on both sides. And I get a is equal to 7 radical 2 all over 2. So there's a. Okay. But I'm not solving for a. I'm trying to solve for x. So I'm going to use the 45, 45 triangle. And the 45, 45 means that, hey, sides are congruent, right? So 7 radical 2 is right here, or sorry, a, which is 7 radical 2 over 2, is right here. If I wanted to find the other leg, I could just easily find it, but I'm going to look for, I'm trying to find x, right? So set this is x. And then we set up another pattern triangle with the 45, 45. So you got 1, 1, radical 2. And here we're going to set it up. So let me highlight that one. This one's the yellow one, don't forget, right? So it's the yellow one for given. We're trying to solve for x. So x we know goes to radical 2. And then we have 7 radical 2 going to 1. So 7 radical 2 all over 2 going to 1. So I know it looks a little weird because we have a fraction within a fraction, but that's okay. We're going to cross multiply. And you got x times 1 is equal to 7 radical 2 over 2 times radical 2. And then you have x is equal to, oops, that's weird. X is equal to 7 radical 2 times another radical 2 all over 2. Well, 7 times radical 2 is going to be radical 4 all over 2. And radical 4 is just 2. So you got 7 times 2 all over 2. Well, hopefully you notice that the 2's cancel out, so we're just left with 7. And there's your final answer. X is equal to 7.